nmap command -st and then the IP address. And if I go ahead and run this, then it's telling us what port is open and then telling us what the default service for that port is.
Hey everyone, Yaniv Hoffman here, and today we have a special treat for you as we dive into the world of Nmap, a tool that every cybersecurity professional should master. And joining me in this session is Master Hacker Occupy the Web. Welcome.
Thank you, Yaniv. I'm always honored to be on your show.
Great to have you here. And if you are not familiar with Occupy the Web, you have a series of exceptional books, some behind me. Linux Basic for Hackers, which is exceptional book as foundation of operating system into the world of hacking. Getting Started, Becoming a Master Hacker, which is a must book, was also chosen one of the top 100 malware books of the century. And the latest one, Network Basic for Hackers, which complete the golden triangle, as I call it, expertise and knowledge in hacking. And on top of that, Occupy the Web has a great community of white hat hackers called Hackers Arise, which is providing a lot of educational and knowledge session. It's actually like a community of hackers, not only on the theoretical side, also on the practical side. We have a discount of 20% of the entire shop there. Use the code YANIV, YANIV, to get it. And with that said, Occupy the Web, again, lovely to have you here. And I'm sure it will be insightful session for our viewers.
Thanks, Yaniv. As you said, everybody, whether they be a network engineer, a server engineer, a hacker, a red teamer, blue teamer, they should all know Nmap. And so I realized that we have never done a tutorial on Nmap, and sometimes some of the tutorials get really too complicated when Nmap is really a pretty simple tool. And so what I want to do today is to teach your viewers the basics of Nmap. I mean, Nmap has a lot of capabilities. You can do a lot of things with it, but probably its most important functionality is the ability to tell what ports are open on the target machine. We'll call it the target machine. Don't call it the victim machine. We'll call it the target machine. So this can be useful as a hacker because a port being open means that there is a service running behind it. Right? The reason a port is open is because there's a service there, like HTTP on port 80, or DNS on port 53, or FTP on port 21, or, you know, you can go on and on. Port 45 for SMB. I should point out that, you know, if you want to be successful in this industry, you should know the most common ports. And, you know, the most common ports, maybe the top 50 or 100 ports. You should have those memorized. And, you know, just create a list, go through them, practice them, make sure you have them so that, you know, you don't, when somebody says, you know, there's a problem with SMB, you know right away that it's port 445. You don't have to go look it up. You should know those basic ports. Right. But this tool will allow us to see what ports are open on the target system. That's what it does. And what it does is that it sends out packets. Packets are those little bits of information that help us communicate over the web, right? We could show you little diagrams of them, but maybe that's, you know, beyond the scope of this class. They're little bits of information that have a way of communicating between systems, all right? And it sends out these packets from your system, okay, to the target system. And then depending upon how the target system responds, it determines whether or not the port is open. And this kind of opens up some kind of basic questions of understanding TCP/IP. And that is that when you're trying to open up a connection on another machine, there are 6 flags, okay, in TCP. Okay, there's 6 flags. And most of your listeners know that when you try to open, okay, a connection, the packet contains a SYN flag. Maybe I can get a diagram out. Okay, I have some diagrams and I can.
Recently, this scanning and listening is even more important because the adversaries, the attackers, are trying to learn the business logic. It's not only which services or port is open,
Right.
Services attached. They try to disguise their attacks to look like a legitimate request. So it will be more challenging for the defensive protection mechanism or systems to identify it.
This is kind of basic TCP/IP, which, it helps if the more you know about TCP/IP, the better you are at using a tool like Nmap. Mm-hmm. And this here is actually the TCP. This is a TCP header. So when the packets go out, right, normally there's TCP and IP are bound together in the packet, right? IP has the information about the IP address going and coming back. In the TCP header, you have the port, right? These are the ports right here. So this is the port it's coming from and the port it's going to, right? The reason I wanted to show you this is that there are these flags. These are flags right here that are in the TCP header. And there's urge, ACK, push, reset, SYN, and FIN. All right? And this are the way that TCP uses to communicate between the host and the target, okay, the client and the target. So that when I want to open a connection, okay, to another machine, another TCP connection, I have a SYN flag. Okay, it sends out a SYN. The target, if it's open, it'll send back a SYN and an ACK. Okay, this is the ACK right here, and then after that, the communication between the two systems will have an ACK flag set on all the communication until they want to close, and that's where the FIN. Right. As in finish comes in, right? Mm-hmm. If I'm trying to open up and make a connection at a port that is closed, then in TCP it'll send back the reset. Okay, the target will send back the server. The target will send back to me a packet that has the reset flag on it. Right? That's how Nmap works. So Nmap goes out and says, okay, it sends out packets with the SYN flag on it. If it comes and gets a SYN ACK coming back, it says, oh, the port's open. If it gets a reset, it says, oh, the port's closed. So it's pretty simple, right? This is not rocket science, right? It's pretty simple. Yeah. It's a three-way handshake. It doesn't have to make the three-way handshake. It's basically what it's doing is just reading the packets that are coming back. If it makes the three-way handshake, I mean, there's actually different types of scans in Nmap, and one of them is the three-way handshake, which is the T scan. But it doesn't need to make a three-way handshake. It can just send out the SYN and wait to see what the response is and never create the handshake. But as you're describing it, we have in TCP, we have the three-way handshake where we get a SYN, ACK, and an ACK.
Right.
So that's the way that Nmap is just using what we know about the technology, the way that communication is taking place between systems. It uses that information to be able to determine when the port's open, right? And so let's just try it out, all right? So let's start, okay? Nmap is built into your Kali, right? So it's on all the Kalis, and it's on a lot of Linux Unix systems. So you may not have to install it, but if you do, of course, you can always go sudo apt, okay, install Nmap. Mm-hmm. That's what you do for anything, right? But in our case, it's built into Kali. It's been built into Kali since Kali was Backtrack 20 years ago. So it's before Kali, before Offensive Security called this operating system Kali. It used to be called Backtrack, and it goes all the way back to the aughts, somewhere around '04 or something like that, when it first came out. So to run Nmap, the basic syntax looks like this. Right? It's just Nmap and then -S for scan, and then the type of scan you want to do. As you said, the three-way handshake would be a T-scan, right? That's the most reliable scan because it determines whether or not a port is open by whether or not it completes a three-way handshake. A three-way handshake is a very reliable bit of information. And then the target IP. All right, that's it. Okay, this simple syntax can do a lot for us. All right, so let's but before we go on to actually do it, I want to just show you a -H in Nmap. All right, and you can see that there's a lot of options here. But what I just showed you, okay, will work in most cases. All right, in most cases, it's going to do the job for you. So lots and lots of. So here's, a lot of different options. Here's the scan techniques, the host discovery, a lot of things that you can do, all right? But in most cases, that's all you need to do. So I have another system on here, and I'm going to go ahead and do an Nmap scan on it, and I'm going to use, this is the most reliable scan, the ST. So it's scan, it's TCP, that's what the T stands for, okay? And then I'm going to go 192. It's on my local network. I think it's at 100. Let me just go check before I scan it. Here's a Windows 7 machine. It's at 9. Okay. So I'm going to go ahead and scan that system. All right. And that's all I have. Okay. Just Nmap command -ST and then the IP address. And if I go ahead and run this, then it'll come back and it shows me look how quick it comes back. It goes and scans all the ports. Now, I got this on a local area network, so it's going to be very quick. Okay? But it comes back and tells me every port that's open on that system. Mm-hmm. Now, what's that do for me? Well, if I'm a network administrator, I know what ports are open on the systems on my network. Okay. I could scan all of the systems on my network, okay, by simply using CIDR notation. So by up arrow, I could do this, right, and have Nmap scan all the systems on my network to determine what ports are open on it. Mm-hmm. So as a network administrator, this is a useful bit of information. I can see I've got 80 open, 135, 139, 445. RTSP, which happens to be, for those of you who watched our hacking IP cameras, know that is the port that's used by a lot of IP cameras. Not all of them. Okay, it's most widely used port, okay, on IP cameras. And there's a bunch of other things here as well, including RDP, remote desktop, right there. Okay, so I got a lot of information from that. Right? And if I were to go /24, all right, I could go and then do all of the machines on my network, and it comes back and telling me that basically only found, what did it find? It found one machine here that's a DNS, this one here.
Yeah.
It's a DNS server.
53, yeah.
Port 53, and then it found the Windows machine. That's all it found. And it's the other ones that comes back and says that there's didn't find any open ports, or in this case, connection refused. As a hacker, what this does for me is it tells me, so for instance, if I see port 554, I go, there's probably a camera there. There's almost 100% chance, not 100, but almost 100% chance. Some people put their cameras on. They'll almost always be 554, but it might be 8 554 or 5 554. but almost always it ends in 554. And as your listeners know, you can put any service on any port, so that this might be HTTP, but it might be something else too. But what this is telling us, the way we have it set up right now, is it's telling us what port is open, and then telling us what the default service, not telling us what service, it's telling what the default service for that port is. A good security manager will move their services to the non-default ports. Why? Because that means a hacker like me, and I see that, instead of 554, right? If I see something that's on like 888, right? I'll go, I don't know what that is. But if you put your camera on port 554, I know what that is. That's a camera right there. And this here is almost always SMB, right? Almost always SMB 445. That's the default. So if you really wanted to be secure, you would move these services away from those default ports, and you can do that. And one of the things that probably is most important is to move the database servers onto non-default ports, right? So that the hacker who's on the outside scanning doesn't know where your database is at, all right? So that's real simple what we did, and we learned a lot of information, right? If we wanted to get even more information, we can use the -A, okay? And the -A now, what it'll do, we can go up to our help screen, and it'll tell us what it does, okay? And let's go all the way up here, okay? -A, enable OS detection, version detection, script scanning, and traceroute. So what it'll do is that it'll try to determine what the operating system is, okay? And it'll actually go in and try to determine what the actual service is on the port and what version of it is. Now, why do we need that? Because, like we said, it could be something else on there. You could put HTTP on port 8080, right? That's commonly done, right? Or it could be put on any port. If you use Shodan, you look at Shodan, you'll find a lot of systems around the world that people don't put. They don't put HTTP on port 80 because it makes it too easy for the hackers to. Yeah, it's too obvious, right?
Because the hacker can understand, one, there is a public-facing application out there, so the public can reach it, right? The second, the port in the firewall is open because it allows, right, access to this application, and then he can shoot his malicious code through HTTP port 80, which will look legitimate request, but actually has a malicious intent.
Exactly. If you're a public-facing web server, you're probably going to keep port 80 and 443 open, right? Because you need that's what all the browsers are looking for. You want to serve a public, but in some cases, you have companies who aren't serving the public. They have web servers that are intended only for internal use, okay? And they might have a login screen, what have you, for just employees and contractors and IT personnel. And they'll often put their web server on another port because that just kind of makes it harder for the attacker to find. But if you're using Shodan, you look at a lot of systems around the world like I do, you'll find a lot of those systems, especially industrial control systems. Industrial control systems almost always have a web server on them, but not on port 80. Okay. So, but this here, using the A, will attempt to determine what the actual service is on that port and what version of it. Why the version? Because vulnerabilities are specific to not only to the service, but to the version of the service, right? So, if somebody has patched their services, up to date, then, there's probably not going to be vulnerabilities there, or unlikely to be. If they haven't patched them for 6 months or a year or two, then there's likely to be vulnerabilities here. So this -A can tell us what version of these services that are running on this system and the operating system, right? So we're just, this is pretty simple, easy stuff. We don't have to, go through all the manuals to be able to figure out this stuff. Pretty simple. It's going to go through, and we're just going through the one system, just the one, to see what we can find out about it. Because it's doing more than just port scanning, it takes longer. Okay, it's doing more work. It's probing. Once it finds a port is open, it then probes to figure out what is actually running on that port, and then what version is running.
Right.
So this is all really valuable information, both to the security engineer as well as the hacker, to understand what's going on in these systems. And this is almost always the first step, all right? If you're a security engineer, you should be doing this on all your systems, so you know what ports are open, because sometimes if you go into a new environment, you've just been hired, you don't know what people left on your systems. There might be all kinds of ports that were opened by default and nobody's using them anymore. And this is a way for you to find out. You want to impress your boss. The first thing you do is scan the entire network and tell them, hey, these ports are open and they shouldn't be, right? This is not secure to keep all these ports open, that we don't need these open.
Yeah. It's basic, but it still works. It's
basic, and it's basic, but it's an important tool. It's a really, really important tool. I think it's the first tool that every network engineer, every security engineer, and every hacker should know. And of course, when I teach hacking, this is the place that we always start, is with Nmap. And I think a lot of books try to make Nmap into something that's a lot more difficult than what it is. It's we can see that we're getting almost all the information we need from just a couple of switches here. This is taking a lot longer because it is doing a lot more work and a lot of ports to work on.
Maybe occupy the web while it's running. Of course, when you do such a thorough or invasive scan, the chance that someone will detect it is pretty high, right? So what are evasion techniques for doing it less invasive, but still, still you can benefit from the scan itself?
There's a lot of different ways to be evasive with Nmap, but I think that maybe we should save that for another video. Right now, I want to keep it really simple. Okay, so here's what we came back. Okay, it finally finished its work, and it did port 80. Okay, and it said it's open and it's HTTP, but it comes back and gives us even more information. Okay, it tells us HTTP is a general protocol, but it comes back and tells me on that port, I see Microsoft IIS HTTPD, the daemon, 7.5. It's an old machine, right? So it's an old version. It comes back and tells me, gives me some information on the header and potentially risky methods. It gives me some more information on some of the other, ports here as well. It tells me this is port 45 is SMB, right? And then it doesn't know what to do with port 554, right? So it can't determine everything. Okay. It comes back and it tells me that this 2869 is HTTP as well. All right. And it has some more information for me and tells me that we have Windows RPC and these other ports here. And then it comes back and says the name of the host. Then it comes back and tells me the operating system, right? So it's given me a lot of information, okay, I had to run just a couple of commands. Actually, I can do this all in one command. Now, one of the things that some of the textbooks will tell you is that if you use the -S like this is often referred to as the stealthy or the SYN scan. In my opinion, it's not stealthy at all, okay? Because the only difference between the S scan and the T scan is the three-way handshake. This one does not complete the three-way handshake. So if you're taking one of those hacking exams and they ask you about stealthy scan, it'll say that it doesn't leave any log files behind. That's not true. All right. So if you use the scan on my system, I'm going to still see your IP address. Okay. The only difference is that the server will not log a connection. So this doesn't save you any trouble, folks. Okay. It's not going to make you any stealthier, even though the textbooks say that. And you can determine that on your own by doing a scan and watching the Wireshark. Right. Let's do that. Let's open up Wireshark. And so we'll open up a Wireshark and we'll look at what actually is being sent across. So many textbooks say this. I get this question a lot. That's why I'm dealing with it. So let's go ahead and do a simple scan, all right, of the T scan without the A, because the A takes a lot longer. All right. And let's open up Wireshark over here. Got this. Give them side by side, all right? And then hit enter, and you can begin to see the packets go across here, all right? So I'm scanning 9, 15 to 9, so it's 192, 168, 109, okay? And what's going out? My IP address is going out to that system, right? It's going out with all the information from the header of the TCP and the IP packet. So if I go ahead now and do an SS scan, the stealthy scan, okay, as it's often referred to, and let's see what comes up then. I got to do the sudo there. Okay, so let's go down and okay. So you can still see my IP address is still, it's still being sent to the target. So that's not very stealthy. So that's where I have some problems with the textbooks and others. Actually, I think Nmap actually calls it a stealth scan in their documentation, but it's not very stealthy. So the important point for the newcomer is don't believe that because you're using the S scan that you are somehow not going to get detected, because you will get detected. Because it's not any stealthier than any of the others, right? Any IDS, any firewall is still going to detect you and log your information. So just kind of keep that in mind. So one of the things that people will often find when they are scanning systems with Nmap is sometimes it'll come back and it'll say, the host is down. And it's not really down. Okay. Why does it come back and say that? Because a good security engineer is going to either drop, okay, or block ping requests, right? That would be a good thing to do. It's like to not allow. So if somebody sends you a ping, right, an ICMP packet, right? So if somebody sends you a ping, you don't return it. So when I go ahead, for instance, I go ahead and ping this system, right? And this is sending out an ICMP echo request, and then it gets back an echo reply, right? This is the way that I can detect whether or not a system is actually available, if it's actually up, right? If it's up and running. So a good security engineer is going to essentially block those pings, or better yet, not block them, but instead just don't respond to them, okay? So that way the attacker, the hacker, doesn't know if the machine is really there, if there's actually a system there. So the reason I went into this is that Nmap, before it starts to do its work, okay, scanning all the ports. So it scans the top 1,000 ports. That means that, keep this in mind, is that if you're trying to find a port that's not in the top 1,000, and remember that there's 65,536 ports, okay, 2 to the 16th power, right? So that's 8 bits. I'm sorry, it's 2 to the 16th power, 2 bytes of information. Okay, so there's a lot of ports out there, and if it's not in that top 1,000, Nmap's not going to find it. So that's a concern we have to have. And the other one is whether or not it's not returning the ping. So that what Nmap does is it goes and sends out a ping first before it starts scanning those 1,000 ports. It sends a ping out first. If it doesn't find a system, doesn't get a response from the ping, it'll go and stop. It'll say, hey, that system isn't even up. Why do you want me to scan it? So in that case, what you need to do, okay, so very often I find this a lot, okay, is I got to go and use a PTN like that, right? What that does is it tells Nmap, don't send the ping. Do not send the ping. All right, so just go out and scan. Don't bother looking to check to see whether it's up or not. Mm-hmm. And this will often, sometimes you'll be scanning systems and it says this system's down. And then you use the PN and you find, oh, it is up, because it's blocking a ping, but it's not blocking TCP. So once the Nmap goes into its TCP scan, it sees the ports that are open, but it won't even scan if it thinks the system is down. So that's an important switch that you want to put in there and remember. It's very important because secure systems very often will not respond to a ping, right? And Nmap does a ping by default, right? The other thing that's important to know is that you can scan for just a single port, right? Like that, right? Scan for a single port. So this way, I just want to check to see whether or not port 445 is open. I don't want to see all the other ports. Right? And this can be also really useful when you're looking for a non-standard, not top 1,000 ports, because, if I'm looking for, one of the things that I do a lot of is I work a lot in industrial control systems. And the ports in industrial control systems are non-standard ports, and Nmap won't find them by default. I have to specify the port numbers. In this case, this is just a Windows system, right? And you can see it came back. There it is. Quickly, just came back. Hey, got Microsoft DS there on SMBs running on that system. All right. So that's kind of, that's the place to get started with at Nmap. And also remember that you can also scan an entire, Class C network or Class B network, whatever, Class A network. Okay. And it'll take a long time, but it'll scan every machine on that network. And as a hacker, you would use this to say, okay, we've found a new vulnerability in SMB. Okay, there's a new vulnerability in SMB, and SMB has had its vulnerabilities over the years. Some of the most egregious vulnerabilities over the whole span of, say, the last 20 or 30 years have been SMB vulnerabilities. So if I find that there's a new SMB vulnerability, I might want to go out and just start scanning systems all around the world, looking for that version of SMB that I can exploit. Right? One of the things that I did in Linux Basics for Hackers is we did a little exercise in there of building a scanner with Nmap, okay, using a bash script to go out and scan for various ports. And it's based upon some work that was done by Max Vision. Mm-hmm. Some of you know Max Vision. I talk about him in my book. Max Vision just got out of prison 2 or 3 years ago after spending 14 years there. Max is famous for running the largest Carter market in the world at one time. Carter market meaning a market where credit cards are bought and sold.
Yeah.
And what he did is that he scanned every night, a subset of the internet, looking for port 5505 open, which was a tech support port, okay, tech support port that was built into this point of sale system called the Aloha point of sale system. And it was no authentication. So he could just go into port 5505 and pull credit cards out of it. All right. So that's an exercise in one of the, I think it's chapter 8 of my book. But we don't use port 5505. We use, I think, 3306, which is MySQL. So this is a simple variation on it to find a single port. It's also important to note that not all ports are TCP ports, right? Some ports are UDP ports, and you will not find them by doing a SS or ST scan, because those will only look for TCP ports. You have to do an SU scan to find UDP ports. And you may not know this, but there's a lot of stuff that runs on UDP, right? For instance, SNMP runs on UDP. Network Time Protocol runs on UDP. There's a lot of things that run on UDP. And so let's do a scan looking for UDP ports, right? And it'll take a little longer. And the reason it takes longer with UDP, and sometimes, if you're scanning a lot of hosts, it can take hours, is because unlike TCP, when the port is closed, it responds. It says, hey, I'm closed. And it sends back a reset.
Right.
But that's not true with UDP. UDP ports simply don't respond. Right? There's no response if they're closed. So Nmap has to sit and wait and say, okay, if I waited long enough, for going through each one of the ports to see whether or not they're open. So it ends up adding a lot of time in trying to do a UDP scan. We might just explain that it just show this and show how long it takes. It hangs. You can see here, I just hit the space bar. The space bar will tell us how much.
70%. Yeah. Okay.
It's 70% done after 20 minutes. 20 minutes. Right? It's 70% done.
Wow.
But eventually it'll finish in 5 minutes or so. And sometimes these estimates are not accurate either. But
yeah.
And it'll give me all of the ports that are open, UDP ports. So, you usually want to check for both TCP ports and UDP ports. Doing TCP ports is quick and easy. UDP ports is a lot slower process. You got to be more patient with it.
Yeah.
But if you just do one UDP port, it comes back pretty quickly.
That's great. So for sake of time, I think that's it for today. Definitely, this is a basic and fundamental tool that every cybersecurity professional should be aware of. And I think you gave us many insight, not only on the common or known things. Also, we spoke a bit about the evasive, that is not that evasive techniques. We see the possibilities with hundreds of script, as you mentioned, maybe around even 700. And I say for everyone, this is not only to understand which port is open and which service it's tied to. There is a lot of now business logic behind it for attackers to try to disguise malicious attacks into legitimate requests, which will make the defensive system have more challenge to detect it or identify it properly. So if you want to hear more, there is the books of Occupy the Web, Linux Basic for Hackers, where he explained in much more details, plus even building, as you mentioned, Occupy the Web, building a scanner as part of it. There is the School of Occupy the Web, Hacker Rise, which Occupy the Web is doing more practical sessions, more 12 sessions about it. And if you are interested even to hear more, leave your comment in the description, Occupy the Web and myself always try to address. Definitely, I'm always answering. I'm trying to answer all of the comments. Definitely would love to do more about it if you guys are interested. And if you are interested in other topics, also let us know. With that said, thank you for watching. Like, if you're not subscriber yet, please do it and check Hacker Arise. Thank you very much, Occupy the Web.
Thanks, John. It was good being here.
Great to have you, and thank you for everyone.